In this video, I will introduce set builder notation. So far, whenever I had to describe a set, I always listed everything out. So for example, the set of all even integers between 1 and 5 would be represented as 2, 4. And obviously this method gets impractical when your set is large. So for example, if I wanted the set of all even integers between 1 and 1 million, this would take me forever to list everything out. So instead I can use set builder notation to help me simplify things by writing out the set like this. So I can write it out as the set containing the elements x, and then I write a straight line. This straight line represents the phrase such that. So we have a set of elements x such that x is an even integer between 1 and 1 million. And this is what set builder notation is. So when we use set builder notation, we write down, first of all, the curly bracket, and then we write down this placeholder variable. So I'll use x over here, but you can actually use whatever other variable you're comfortable with. And then we write down this straight line, which represents the phrase such that. So this straight line represents such that. And some people like to use a colon instead of a straight line. I myself prefer using a straight line, so that's why I'm using a straight line, but you can also use a colon. So after you write this straight line, this represents such that. And then after the straight line, you write down a condition. I'll just use p of x to represent this condition, that all elements within your set must satisfy. So for our example, our condition was x is an even integer between 1 and 1 million. And so for every single element within this set, it must satisfy this condition in order to be in this set. So you can actually control what you have inside your set by tweaking this condition over here. So for example, I can set this condition to be something like x is a planet in our solar system. And in that case, we would be left with a set containing the 8 planets. And so this is what set builder notation is. We can also use set builder notation to extract a subset from an existing set. So let's say, for example, A is the set consisting of the numbers 1, 2, 3, 4, and 5. Now I want to define another set, B, to contain all the numbers within A that are even, and we can use set builder notation to express this. So we'll write this out as x, the set consisting of the elements x, which are elements in A, such that x is even. And so this effectively extracts every single even element within A, and then we'll dump them inside B. So you see that this is pretty similar to our previous example. The only difference is that this time we've specified that all the elements in B must come from A, and then all the elements in A that satisfy this condition will be dumped inside B. And so this is how we can use set builder notation to extract a subset out of A. Now before I end this video, I just want to point out one last thing. So in our first example over here, we use set builder notation to generate a completely new set. In our second example, we already had a set, we had set A, and then we use set builder notation to extract a subset out of the original set. And then it turns out that using set builder notation, like in our first example, is actually very dangerous, because if we set our condition p of x to something crazy, it can actually lead to logical paradoxes. So the example I just showed you was simple, so there was no logical paradox here, but in the next video I will show you how we can actually break mathematics by tweaking this condition here. If we make this crazy enough, we can actually break mathematics.